Hey, welcome back. This is section 6.6 on solving exponential equations. So, an exponential equation is something of the form, say, like 2 to the x equals 16. Right? Excuse me. So, in order to solve this, there's a couple of nice rules. I mean, this one's fairly easy. If you have an easy one like this, where 16 is simply 2 to some power, right? 16 happens to be 2 times 2 is 4 times another 2 is 8 times that fourth 2 gives you 16. So we've seen things like this that are nice, right? 2 to the x equals 2 to the 4. Obviously, x has to be equal to 4, right? But there's a nice property of logarithms that we're going to look at. And that property is, it's called the power rule. Of exponents. And it says this: if I have the logarithm, whatever log, it doesn't matter, log base anything, of something with a power, right? So the base doesn't matter, the x doesn't really matter, but if there's a y here, the nice part of this is I can say that this is the same as y times the log base a of x. If it's a power of the thing inside the log, it can come down as a multiplier in front. Right? So specifically, I might see something like, say, the log of x to the fifth. I can say that this is the exact same thing as taking 5 multiplied by the log of x. Right? And you can verify by throwing in a couple of examples. If I plug in, let's say, the log of 25, right? Because the log of 25 is the same as saying log of 5 squared, because that's what 25 is 5 squared. So I should be able to say that this is 2 times the log of 5, right? And if I plug in the log of 25 into a calculator, I get one value, which is my calculator's not playing nice with me. There we go. 1.39. And if I plug in log of 5 and then multiply that by 2, I also get that 1.3979 never-ending number. So you can try it. It's going to work. As long as you input into the calculator correctly, you should be able to verify that this is true. Okay. So, excuse me. Again, if I don't need it though, right? If I have something like, say, 3 raised to the x equals 27, I might be able to just get away without having to worry about logarithms at all, because 27 happens to be 3 to the third, and so if I have 3 to some unknown power is the same as 3 to the third power, well, that power is 3, right? There's no magic here. It's just saying if you have one number raised to some nebulous, I don't know, power, but that's the same as 3 raised to this very specific number power, well, that nebulous power is that specific power. And there's no guess. It's it, right? So if you can write the right-hand side or the non-exponentiated side as a power with the same base as the other side, then you just do that. There's no logarithms required, right? And it may get tricky. You may end up with something like, say, 4 to the x equals 8, right? But 8 is not a power of 4. It's a multiple of 4, but it's not a power of 4, right? 4 to the 1 is 4. 4 squared is 16. We skip over 8. But we can rewrite this because 4 and 8 are both powers of 2, right? So instead of 4 to the x, I'm going to write 2 squared to the x. Just rewriting my 4 as 2 squared. Nothing tricky yet. Well, nothing tricky at all. But 8 happens to be 2 to the third. And if I have a number raised to a power raised to another power, I multiply those powers. So this simply becomes 2 raised to the 2x power is equal to 2 to the third power. They're now rewritten with the same base. So I have 2 to the 1 power is equal to 2 to a different power. Well, those powers can't be different. 2x, the power on the left, has to be equal to 3, the power on the right. Divide by 2, and we're done. And x is equal to 3 halves. Voila. Right? Okay. Now that works as long as you can use the ability to write both of the sides as the same base to some exponent, right? Excuse me. So if I have something like, say, 2 to the x equals 0.25, right? How do I play with that? It's a decimal, oh my gosh, it's ugly. But 0.25 is 1/4. So this is then 2 to the x equals 1 over 4. And 1 over 4 is a power of 2, right? Because 4 is a power of 2, so that's 1 over 2 squared. But 1 over 2 squared is the same thing as 2 to the negative 2 power. And therefore, if 2 to the x is equal to 2 to the negative 2, well, x has to be negative 2. And we're done. That's that. Okay. Okay. If, however, I have something like 3 to the x equals, let's say, 8. Right? There's no way that I can turn both of these into 3 to some power just by saying, well, 3 to the 1 is 3, 3 squared is 9. I'm skipping over 8 altogether. The point here is that x is going to be a terrible number. It's going to be an irrational number. There's no way that I could guess it. And so I have to use logarithms, right? But that's the beauty of the logarithm is here I can take the log. Let's take the natural log of both sides. So if I take the natural log of the left-hand side, that just turns into the natural log of 3 to the x. But if I take the log of the left-hand side, I have to take the log of the right-hand side, so then this is then equal to the natural log of 8, right? And as long as I do that, take the log of the left-hand side, it should still be equal to the natural log of the right-hand side. And I'm going to use that power rule that says, hey, this x is a power inside of something that's being taken the log of, move it to the front. So that's the nice part of this, is that now I have x multiplied by the natural log of 3. X is not in an exponent anymore. It's hanging out here as a multiplier. This is equal to the natural log of 8. But the natural log of 3 is just a number, right? I don't know what it is, 1.2 something maybe, but it's a number. So I have x times a number, but if I want to get x alone, I then just divide that number, the natural log of 3. And I'll do that on both sides. So then x, in the end, is the natural log of 8 divided by the natural log of 3. And if your application or your homework or whatever it is asks you for an exact value, that's it. Don't evaluate these in the calculator. It's natural log of 8 over natural log of 3. If it asks you to evaluate it or approximate it or find some number rounded to whatever decimal places, then you have to throw this into the calculator, take the natural log of 8, divide it by the natural log of 3, and see what you get. And so let's see what I get here. I get 1.89. And usually I think in the homework they ask you to round it to 3 decimal places. So let's do that here. I get 1.89, 2789, and blah, blah, blah. Some more junk after that. I really just want that third digit. The next one after it is high enough to justify an increase. So I would write this as 1.893, and that's my approximation. Let's take a look at another one of those. We'll go through another example. Let's say I have 7 to the x equals 300. Let's go with that, right? So again, I can't write 300 as 7 to some power. I mean, I can. We're going to figure out how to do that, but I can't write it as a nice power. So I'm going to take the natural log of each side. So here I have natural log of 7 to the x is equal to the natural log of 300. Right? Again, that very powerful power rule says that the x can bounce down and be a factor instead of an exponent. So I then have x times the natural log of 7. And again, that natural log of 7 is just some number, right? Something close to 2. But since it's just a number, that means I can divide it, and cancels out of the left-hand side, divide it to the right-hand side, and my x is then just whatever the natural log of 300 divided by the natural log of 7 is. I can evaluate both of those into a calculator, so I'll take natural log of 300 divided by the natural log of 7, and when I do that, I get 307 is 2.931. So if you're rounding this to 3 decimal places, 2.931 is it. All right. Let's solve a little bit more involved one of these. Let's say I have 5 to the 2x minus 1 is equal to, I mean, it doesn't matter. We're going to end up with an ugly number. Let's just call this 800. For, why not? Again, I can't write 800 as a power of 5. It's a multiple of 5, but it's not a power of 5. And so I can't write the right-hand side as 5 to something, right? So I take that natural log again. So I take the natural log of the left-hand side, that is natural log of 5 raised to the 2x minus 1 is equal to the natural log of 800. And I'm going to use that power rule here, which means the exponent of 2x minus 1 comes down as a factor, but since it's a binomial, I have to be careful here. It is a factor, so I'm going to leave it in parentheses in front, 2x minus 1, because that whole thing gets multiplied by the natural log of the 5. Right. Now, again, if I just had an x here, I would divide that natural log of 5 away. I can still do that because this 2x minus 1 is a factor. So I can divide both sides by natural log of 5. And on the left-hand side, the natural log of 5 cancels with the natural log of 5 because the natural log of 5 is a factor in the numerator. And that leaves me with 2x minus 1 on the left. And then this fraction, the natural log of 800, divided by the natural log of 5. Right. And I still want to isolate this x. So this natural log of 800 divided by the natural log of 5 is just a number. I don't know what it is, but it's just going to be a number. but I can always still use those addition principles and multiplication principle of equalities. So here I'm going to add 1 to both sides. Move this up here. By adding 1, I get rid of the 1 on the left-hand side, and that leaves me with just 2x on the left-hand side. Here I have the natural log of 800 over the natural log of 5, which is again just some number. So I'm just going to write it here, natural log of 800 over the natural log of 5, but then I'm adding 1, so plus 1, right? I'm still not there because I've got my 2 multiplied by this x. I want to get the x alone, so I'll just divide both sides by 2. So divide this by 2, and I'm going to divide this whole right-hand side by 2, which again is not going to be the most pleasant expression, but it's going to work for us. So that isolates my x on the left. My right-hand side is this natural log of 800 divided by the natural log of 5 plus 1, all then divided by 2. So you have to be careful when you throw this into your calculator. This is a big expression. It may be best to start here, take the natural log of 800, figure out what the natural log of 5 is, divide the 2, add 1, and then divide the entire result by 2. Some calculators you can throw this whole monster in. In fact, I will show you in Mathway how to do that. And I'm showing you this, but beware that you may not be able to use Mathway on your final. So let me throw this in here. So we have Mathway. If you just go to mathway.com, there we are. I don't know if this is focusing very well, but I'm going to type it in. So I'll try to type it so you can see. But I would go the natural log, which is right here. So natural log and then open up a set of parentheses. In here in Mathway it's not necessary, but I like it, so let's do it. Just divide by let's see here. This isn't doing what I want it to. Alright, so we're going to be a little more careful here. I'm going to put this natural log of 800 in parentheses because it's trying to get me to divide the 800 and not the natural log. So I'm going to plug the natural log of 800 in parentheses and then divide by this natural log of 5. Right. And then I'm going to add 1. Right. But I have to be careful because if I'm going to divide this entire thing by 2, I need parentheses. So I'm going to throw another set of parentheses around here and open it up where it's suggested. Oh, I don't know what it's doing with all these fractions. It's not helpful. Right? So I've got my outer set of parentheses there. And then at the end, I'm going to just divide this whole thing by 2. So it messed it up as I was messing around with it. My 800 in the top ended up as being something psychotically weird. I don't know why. But that's what I want. The natural log of 800 divided by the natural log of 5 plus 1, all in parentheses, and then divided by 2. And if I hit enter, it's going to ask me, are you sure this is what you want to do? And here I have a decimal form, 2.57669, yada, yada, yada. Right? So whatever calculator you're using, know how to use it. Again, you may have to go, Mathway is not my favorite. I if we're being honest, I hate it. I use a different program. But know how to use the calculator that you use and figure out, this kind of material. So hopefully that was helpful. If you have questions and I'm your instructor, please let me know. If I'm not your instructor, email your instructor about calculator issues, and however you get that taken care of, make sure that you're prepared to use the calculator that you're allowed to use on your final exam. Know how to use that. So, all right, thank you, and I will see you for the next one.